Just real quick, go back today, the objective. We're talking about logarithms and the properties that logarithms have. Here's a list of those properties, and like I said a minute ago, the multiplication is directly associated with addition. Division is associated with subtraction, and then you've got the power property. The first two we'll take a look at in a minute once we do a few problems, but the last one I do want to take a second and explain the way what it means. A lot of times we write these things and we really don't know what's going on. It's like, that's pretty, but what does that mean? So let's talk about this. So it shows up as log base b of m to the n power. Do you see that? So it's a logarithm, but the supposed answer in this case is actually a power itself, isn't it? What the power property is saying is if I do have the situation, I can take this exponent on my answer and I can kick it to the very front and make it a product of that. So it would be n times the log base b of m. And that's all it's saying. Make sense? It's really cool. And you can go the other way too. If I do have a multiplier up front, I can take that multiplier and I can kick it to as an exponent on the answer, or where the answer is supposed to be. So it can go either way, vice versa. Make sense? It's not a hard thing, is it? So.
If we really said, like, you're really weird, would it come out on your video?
It is. It just did.
Cool.
Yeah, this is live right now, so anything that we say is going to be recorded on there. Here's the next property which I really like. It's called the base change formula. And this base change formula, I got it right away, and it helped me a lot when I was in college. It looks kind of weird. I'll explain that to you as well. This is saying log base b of m. So let's start with just a basic logarithm. I've got a log with a base, and I've got the supposed answer here. And I want to be able to change the base. I can do that, and the way I just remembered simply was just throw a slash through here. Follow the natural line that goes there, and it's going to look like this. And I can rewrite that as log m log of b. So I've got log of m, log of b. Now, why is this called the base change formula? Well, right now I chose a specific base by writing it the way I have it. What base is that? In red. What are my two logs in the base of? Think back to yesterday. If there's no number there, 10, right. So I've written those two with log base 10. Now the reason why I like log base 10, look at the front of the calculator. There's a button there that says log by itself. Guess what base that log button is in? 10. So it helped me just fly through those type of problems that I wanted to find the quotient of or whatever. Now, that's my preference. But because this is a log base change formula, I can pick any base that I want. Maybe I don't want that to be a 10. Maybe I want it to be a 3. I can do that. Maybe I want it to be a 4. Maybe I want it to be a 5 or a 10. But that would totally depend on you and what you think best fits. Make sense? So I can take a logarithm as this, and I can apply my base change formula, and I can change to any base that I want. Cool stuff? Yeah. Cool. Move on. So let's do this for real. Those of you guys that are just starting in the class, I kind of have this little rule that I kind of like. I want you guys to watch me do the first problem. Just watch me. Don't write anything down. Don't look away. Just watch me do the first problem. When I'm done, you can copy all you want. The problem with people taking notes while they're trying to work is that you miss what I said, and then you're like, what did you do to get that? And it just takes longer sometimes, and you miss stuff, and we end up doing things more than once. So watch me do it. I'll let you copy, and then you guys, we can do another one that I'll let you do on your own. So let's simplify some logarithms. Here we go. Forgot to clear that. So I've got these two logarithms. I'm trying to condense it. I'm trying to simplify it. I see that I'm subtracting the two. And what is subtraction related with? Division. So I'm going to turn these into a quotient. Now I do want to make sure that they have the same base, because otherwise I can't do this. Okay? So they do have the same base, so this is going to become log base 4, and then the two supposed answers are going to become a quotient. So I've got 32 over 2. Oh, I can divide that. That becomes log base 4, 16. So I've simplified this now. That is technically simplified, right? Now let's answer the prompt. Okay, if I was to evaluate that, what is log base 4 of 16? Think about the question. When I'm looking at log, what is the question that's being asked? What is this a prompt for? For an exponent. So 4 squared gives me 16, doesn't it? So what is log base 4 of 16? 2. 2. So this, my friends, is simply a really fancy 2. What's up?
So when you're doing this, the bases have to be the same?
Yes, they must. That's the fanciest 2 I've ever seen.
I'm gonna write all my 2s like this.
That's crazy. Dude, on your bank account, are you writing a check?
People will be like, I got a lot of money.
That'd be great. Write a check that way, right? How much is this check for? Do the math. That'd be great. Thanks for the laugh. Thank God for debit cards. Anybody still use checks? No? 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 I remember writing my first check. I was all happy. Back then, nobody would accept like check number 1, check number 2, check number 3. It was very rare. And the reason behind that was you just started using checking account, which means that you still haven't built like confidence, not confidence, but like, oh, what's the word I want to use? You weren't trusted very much if those were the first checks you were writing, because if they bounced, then, you know what I mean? So a lot of people would like throw away the first books and start with like 100 something or whatever. I remember I had to do that. I was mad. Because checks were expensive back then. No, they was like, what's a check? You guys know what a check is, right? Okay. I'm just checking. Oh, sorry. Which one did I do? Was this one? Questions on this? Thumbs up, thumbs down. We're good? We're not good? A little sideways. Easy, yeah? Swing better. Do that one. Do that one. You can do it. And I'm going to call one of you guys for the solution here, so you might want to check and double check your work. Go. Question goes to, I should have taken her out. Disrespect. Oh, there isn't any. Do it again. Mac. Karma. What do you got?
Probably wrong, but I got, I don't know. I don't know.
So this is an addition problem, which means we're going to be
Multiplying?
multiplying, right? So what's my log going to be? With a base of 4. And I'm going to take 5x and I'm going to multiply that with my 3x, correct? So when I simplify this, I've got log base 4 of 15x squared. Good job, man. We're good? We're good? Try this. Try this. Just a heads up, we are past the middle of the chapter, which means tomorrow you'll be doing a mid-chapter quiz. Tomorrow. And Friday we'll be doing our pretest for Galilean. So, yes. You always want to make sure that you take that seriously, yes. Yes, yes, yes. In English.
Wait, so this one's going on a great book, this Galilean one is?
We're taking a quiz and a pretest?
No. Tomorrow you take your quiz. Friday you take your pretest.
Oh.
Alright, so here we go. Question goes to Dylan. Dylan like Dylan.
I don't know if it's right.
I don't matter. What you got?
11 log 2 and x times 2y. I don't know.
I see what you did there. We first got to make sure that we apply that power rule. Okay? So, because I had that 6 and that 5 up front, I want to make sure I kick those up. So this becomes log base 2 of x to the 6th. You see what I did with the 6? I kicked it to the top. And then the other one becomes log base 2 of y to the 5th. Now they're both log base 2, and this is an addition problem, which means I can write them as a product, yeah, multiplication. As a product. So log base 2 of x to the 6th times y to the 5th. And can I really multiply those two? Now, so guess what? Dun, dun, dun. Zach, you all right? I'm losing now. Losing now. Come back. Thumbs up, thumbs down. We're good. We're not good. Yeah, it's just a matter of knowing those rules. And this one threw in the other rule. So, tell you what. Let's see if we can try this out. We'll go the other way now. So we're going to go and we're going to try to expand them using those rules, okay? So, here's our first example, which is done. Let's clear that up. So here we have a quotient. Because it is a quotient, I can write these as a what? As a difference, aka subtraction. So as a difference. Now, before someone asks, the order does matter. Because remember, we also have other properties that we have to worry about, right? Especially with addition and subtraction. Properties like commutative. Is subtraction commutative? Is 7 minus 4 the same thing as 4 minus 7? No. So I have to be careful with that. So I always start with the top one. So we're going to go log 4x minus log of y. Now, something's different about this problem. What's different? You can't subtract them.
Oh, you don't have the base.
I don't have a base. Do I not have a base?
Yeah, you do.
You
Right, technically it's 10, but is there anything else that I can do at this point? No, we're good to go.
This is working backwards, you said?
Yeah, this is expanding them instead of trying to simplify them. I could actually keep going if you wanted to. Does anybody see why? What is that? That is a product, isn't it? That is a product. That means that if I have a product, I can write them as a sum. So log of 4 plus log of x minus log of y. Ah, pretty cool, huh? Yeah, yeah.
So is that the final answer?
Is that the final answer? There is no answer. We haven't answered anything. But I know what you're asking for, and I think that's as far as we can go.
So,
Unless you want to actually figure out what log 4 is. I mean, we could. So technically, we could keep going further. Right, Jacob?
log 4 would be like 6020599.
Do that fraction. Go math fraction. See if it gives you something nice.
I don't know.
No, it wasn't nice.
No, I don't know how to do that.
Oh, just hit math. And then the first option should be fraction, so push enter and then enter again. Let me check it here. Log 4.
Oh, no, just
Math.
stay that in the decimal.
Yeah, so that means it can be simplified to some nice. So if I wanted to get all, y'all don't want to change it. Because once I've changed it and I've rounded it, then it's not the same number anymore, is it? So there we go. That's as good as it gets. Okay? Next. Here, you try this one. Go, 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 go.
I was joking.
Wait, is that a pen?
You heard my All right, question goes to Faith.
So I got log base 9 of x to the 4 minus log base 9 of 729.
Okay, what else did you do? As far as you got?
You want to simplify it more, don't you take that 4 and put it in front of the log?
Yeah, so something else we can do to simplify is grab this 4, kick it to the front. So this becomes 4 times the log of 9, base 9 of x, minus So I've been thinking about, what is a logarithm? It's asking for an exponent. So can I put an exponent on 9? Can I put an exponent on 9 that gives me 729? And that exponent is 3. Blowy kisses. That's so sweet. Now, if you don't see it, then the fastest way, I'm going to do a log base change formula. I'm going to go log 729 divided by log, what is it, 9? Oops, I did this wrong. Log 729, close parenthesis, divided by log 9, close parenthesis, and you're going to get 3. Okay? So here we go. Anything else we can do? So,
Okay. So on the calculator, how would you do the log without doing just the 10? Switch it to 9.
you want to just do the whole top part? You want to enter it just like this, right?
Yeah.
So what you're going to want to do is you want to hit that math button, push up twice, and it'll say log, and then it'll say base with capital, and that will let you plug in a base and the supposed answer. Okay? But you do want to get good at, you guys want to do one more, or are we good? We're out of time? Oh yeah, have fun. You guys want to do one more, or are we good? Okay, try this one, go. All right, have a good one. Question goes to? Wait, you're pretty fast. Yo, Gavin. Here we go. Question goes to Zach. What'd you come up with?
Log base 3 minus 250.
Of 250?
Yeah, minus log base 3. 37.
Okay. And can we simplify this any further?
No.
Nah. Not really. What's up?
So when you're putting 250, do you kind of write it where the exponent would be, or do you just keep it at the same level as the
No. Let's say I had 50x. It's all on the same level. So is the 250. So this would be like, let's say this is the level. I've got log 250. The 3 is subscript, so it goes like that.
Okay.
That make sense?
I thought so, but I just wanted to be sure.
Yeah, exponents would be up higher. You gotta worry about those. Okay. Thank you for asking. All right, I want to do before we go some of these base change. So I've got something like this, base change. Obviously, you can throw that into the log base feature, but you also need to know that there's sometimes a faster way if you know what you're doing, or you kind of recognize those numbers, I should say, not know what you're doing. This would be, log 27 over log of 81. But I noticed that both of those have a cube root, don't I? Can you see that? So if I did it, sorry, they're all multiples of 3. So if I did the 3 in there, then what exponent on 3 gives me 27? 3, right? So that would become 3. And what exponent on 3 gives me 81? 4. So that's just 3/4. Now, that if you can recognize and you see it, but some of us don't and we're in a hurry, then feel free to use that log base feature or do a base change. Okay, in this case, I changed the bases to be 3. But if you did, here, go ahead and do this in your calculator. Go log 27 and then log of 81. Guess what you're going to get? 0.75. You're going to get the same thing. Doesn't matter what base you use, you get the same numbers, which is really, really cool. Okay?
Can you go over how you got base 3 again?
Well, remember, this is supposed to be the base, right? So the question that this is asking is, what exponent do I put on 3 to get 27?
But where did you get it?
We recognized it. Yeah, we picked it.
Oh, okay.
See how down here in red? That's what it would have looked like. What is the base there? 10. And the point I'm making is, with the log base change, it doesn't matter what base you use. You could have made this log base 4, 27 over log base 4, 81. Guess what you're going to get? Same thing. You're going to get that 3/4. You could pick that to be a 5, 12, your favorite number, and it'll still work. Okay? But personally, I go with that one. It's just easier because the button's right in the front. It's probably faster to type that and get in there and try to dig stuff out and plug stuff into the template for the log base one. But that's it. Okay? Any questions on anything I've done today? Fist of 5, show me how well you think you got. Actually, you know what? Exit ticket. jmunoz.me/exit. Let me know there.